Hello everyone, I'm Brandon Ordonez from ECE31 and today I'm going to perform our experiment number 6 for our power electronics laboratory. Brandon's Vlog. The objectives of this experiment are to simulate the controlled half-wave rectifier with RL load using PSpice software, to determine various quantities such as average load current and RMS load current using PSpice software. Hello everyone, so now let us perform our experiment number 6 for our power electronics laboratory. So, the experiment is called controlled half-wave rectifier circuit with RL load. So first, open up OrCAD. Then create new project. After that the window was loaded, build the circuit. Now after building the circuit, let us now edit the configurations. Now after building the circuit, go to place, part, there, special. If you can find it, just click browse file and special. There. Param, and param should be here. Now double click param, then new property, alpha, give it a value. The first value is 30. Oh no, the first value is 45. There, apply. Next, frequency 60. Apply. There. From here, alpha and frequency would appear. There. Click display, name and value. There. Then go back to your circuit and create a simulation profile. Here 16, the runtime should be 16.67 milliseconds since 1/60, which is our frequency, is equal to 16.67 milliseconds for a period. Maximum time step 10 microseconds. Apply. Okay. There. Now run the simulation. So after clicking simulate, the PSpice window should appear. So add trace. First, let's add the average current flowing through the resistor. Then let's add the RMS current flowing through the resistor. RMS current flowing through the resistor. There. So just go to the end of the waveform, since we measure the values at the end of every period, which is 16.67 milliseconds. The average current is 1.9372 amperes, while the RMS current is 3.12 amperes. When alpha is 45, the average current is 1.9372 amperes, while the RMS current is 3.12 amperes. Next, let us increase the value of the alpha. So let's double it. Let's make it 90 and run the simulation again. So after running, add trace, average, IR1, add trace, RMS, IR1. There. So now let's measure. At the end of first cycle, the average current is 1.0631 amperes. The RMS current is 2.046 amp. Now let's increase again the alpha, the value of alpha. Let's edit it. Let's double it. Let's make it 180. And then run the simulation again. Add trace, average, IR1. Add trace, RMS, R1. There. So now let's measure. It appears that the values became very small. So for the average current, it's 53.808 microamperes. While for the RMS current, it's 84.616 microamperes. So what happens if we make the value of alpha lower? So let's try 15. Let's make it 15. So let's go here, hit 15, simulate. After simulation is done, add trace, average, IR1, add trace, RMS, IR1, there, and measure. So at the end of one cycle, the average current is 2.26, while the RMS current is 3.4233 amperes. There. So again, for the last time, let's decrease the value of the alpha. Let's make it 5. Simulate, then add trace. There. So measure. First, the average current is 2.2992 amperes. While the RMS current is 3.4491 amperes. So we can observe that as the value of alpha increases, the value for the average current and the RMS current decreases. Because at 5, it's 2.2992 amperes. For 15, it becomes 2.26 amperes. For 45, it becomes 1.94. For 90, it becomes 1.06. And for 180, it becomes 53.808 microamperes. The same happens for the RMS current. As the value of alpha is increased, the value of the RMS current decreases. So that is it for our experiment number 6 in power electronics laboratory.